So it's a situation here where if we buy a set of cards from a particular auction, what we have is a 15% chance that in that pack of cards there is a rare card. Now what we want to do is find out that if we buy 5 packs of cards, what's our probability of finding at least one rare card. So the way to go about this is to work out what actually happens. So we buy 5 packs of cards. So we either do or we don't find a rare card. So our probability equals 0.15. That's our 15%. And our chances of not getting a rare card is 1 minus that. So 1 minus P equals 1 minus 0.15, which is 85%. Okay, so that's one thing. Now the chance of picking a rare card is consistent, and each pack of cards is independent of the next. And we've got a set number of packs of cards we're going to buy. So this we can model up with the binomial distribution. So if we put R as our random variable, that we find a particular card. So R would be distributed binomially. So we have a B, and then in brackets, we put 2 parameters. The first one is the number of packs we're going to buy. So that would be 5. The second one would be the probability of actually finding the rare card, which is 0.15. So with that now, we want to find out what's the probability of finding at least one card. So we want the probability that R is greater than or equal to 1. And obviously that's out of 5. Now, the other way to write this would be 1 minus the probability R is less than or equal to 0. Now, as 0 is the least we could find, we can also write that as 1 minus the probability R equals 0. This is a slightly easier calculation to take care of. Now in terms of the binomial distribution, the way we could calculate this one, so I'm going to write, that's all going to be our calculation. What we'd have, so we'll start off again with this because that's our original question, because it equals to that. That equals 1 minus, and then I put this in a big bracket because it's going to be one calculation. It's going to be 5 choose 0. So that's 5 choose 0. And then we multiply that by the probability of the number of cards that are rare cards that we find. Well, if it's more than one, at least one rare card, and it's the probability of 1 minus R equals 0, then we have our probability, which is 0.15 to the power of 0. And we multiply that by the probability that it's not a rare card 5 times. So that would be times 0.85 to the power of 5. So that's our probability there. So that's our 0.85. So now what we do there, we do 1 minus, and then that will come to, if you type that in, that's just a 1. That's a 1. And then that becomes 0.4437 and so on. So then this becomes 1 minus 0.4437, which equals 0.5563. So if our answer is 0.5563, in terms of a percentage, that'd be 55.63%. And that will be our probability of finding at least one rare card. So that could be 1 card, 2 cards, 3 cards, 4 cards and 5 cards. Okay.